Hello students, the next and the final topic for this chapter polymer is biodegradable polymers. You know that nowadays people are really struggling with the chemicals all around us, and polymers are mostly synthetic, man-made, and it's a challenging task, to dispose them, as most of them are non-biodegradable polymers. So the lot of work has been going on in creating biodegradable polymers. It is very surprising when people started comparing that most of the naturally occurring polymers, like such as starch, protein, etc., they degrade on their own without any effort, whereas man-made polymers are so very difficult to degrade. So they tried to find the reason behind and tried to find the structural differences, and lot of work has been going on and lot of scope in this field now. So people are really trying hard to create polymers which will be biodegradable. Nowadays, I think we cannot think our life without polymers. Most of us, we don't carry a shopping bag while going to the market, because we are so used to that we'll be given our whatever we buy in the plastic. Can you think your life to you brush your teeth with charcoal or a stem of neem? We don't think our life without polymers now, but it will be very nice if we can replace these non-biodegradable polymers with the biodegradable polymers having the same qualities. So some of the efforts which has been fruitful, and there are quite a few, but only two we need to do in this syllabus. So what are biodegradable polymers? As the name suggests, you can understand the polymers, of course man-made, which can be degraded naturally. These are called biodegradable polymers. So the two compounds which we need to study is, one is PHBV, which is a polyester. We have already learned what are polyesters. And there is nylon 2, nylon 6, which is a polyamide. We have done three types of nylon, two already finished, nylon 6,6 and nylon 6. Now we will be taking up the third type, that is nylon 2, nylon 6. I hope by this time you can already guess nylon 2, nylon 6 means one of the monomers will have 2 carbons and the other monomer will have 6 carbons. So let us begin. The full form of PHBV is poly beta hydroxybutyrate. So P for poly, B for butyrate, hydroxybutyrate, and polyhydroxyvalerate. Okay, so there are two monomers, if you can remember the name. One is hydroxybutyrate, another is hydroxyvalerate. Again, they are named by their common names. Now what is beta hydroxybutyrate? So you can see here, since it is a polyester, it must be having carboxylic acid group as one of the monomers and hydroxyl group as one of the monomers. So here, interestingly, the same monomer contains carboxylic acid group at one end and OH group, that is hydroxyl group, on the other end. So this is a copolymer because we are using two different monomers to create the polymer. So what happens here? With respect to COOH group, this carbon is alpha and this carbon is beta. So at beta position, what we have? Beta hydroxy. So you can see here, we are at the beta carbon, we have the OH group. And why butyrate? Because it has altogether 4 carbon. 1, 2, 3, 4. Okay. So that's how, if you try to remember, then you need not struggle much in remembering them. So what is the purpose that I am showing, projecting the OH group and COH group at the two terminals? Because these are the sites at which polymerization will take place. So this is one of the monomers having COH group at one end, OH group on the other end, and having altogether 4 carbon. That is beta hydroxybutyrate. And what is valerate? Valerate is nothing but beta hydroxy, for 5 carbon. Here we have 1, 2, 3, 4 and 5. So here also I am projecting the OH on the other side. So when you take N molecules of beta hydroxybutyrate and N molecules of beta hydroxyvalerate to form the ester, as you know, the carboxylic acid will lose OH and the alcoholic group will lose H to form water. So a linkage will form at this point, which is an ester linkage. So at the other end again we have OH group, which is capable of linking with another carboxylic acid of another molecule. So since we have taken butyrate here, this side we have taken valerate, so this end also will have another valerate. So what is important for you to know, how to write the polymeric structure. So as you can understand here, from here OH group, H will be lost, so we keep the O here. I have missed out, this O should have been here. Okay, then CH, CH3, then CH2 here, then COO, that is the ester linkage, then again CH, then CH2, CH3, then CH2, and from here again OH will be lost, so CO, and the whole thing will be repeated n times. Please put a O here, I missed out a O here. So that's how we get the PHBV biodegradable polymers. Now what happens here? You know that when some of the medicines which we take, some are coming in the form of tablets, some are coming in the form of powder, some are coming in the form of liquid, some are coming in the form of capsules. And if you have noticed, the capsules, the coating looks like plastic. But when you are taking the capsule, the medicine will be slowly released in your stomach. So those medicines which should not be acting on your body immediately, those medicines are stored in capsules. If you try opening, you can open the capsule. Just two ends you can pull, you can open the capsule and see there is some powder inside. Now what is that coating? Capsule coating is made up of. The capsule coating is made up of this PHBV. Okay, so it slowly melts inside the stomach as it is a biodegradable polymer. Then we move to the next biodegradable polymer, that is nylon 2 and nylon 6, and it is a amide polyamide. And we have just learned that for amide you need a carboxylic acid group and you need an amino group. And interestingly, both the functional groups are present in the same compound. One of them is the first member of the amino acid family, that is glycine, which contains 2 carbon. That's how you get the name nylon 2, COOH, CH2 and then NH2. And the other one is caproic acid. Caproic acid, the same acid which we get for nylon 6 from hydrolysis of caprolactam. Let me try to show you. Yes, this is the one. This is your caproic acid which you have used for preparing nylon 6 from caprolactam. So you take caproic acid, which also has a COOH group and NH2 at 2 ends, and another monomeric unit you take is glycine, which is the first member of the amino acid family. So one end, this end OH is lost, another end H is lost. We take both the molecules n number and from each end we lose water molecule. So I write -2 NH2O, and the linkage which is formed, if I take away water from here, I get a CONH group here. This is the amide linkage. So nylon 2, nylon 6 we get. Now you know that there are quite a few polymers. I mean, when you are people are undergoing surgery, some of the stitches which are given, they said you need not come for the removal of the stitch will vanish on its own. So why does the stitch vanish on its own? Because it get degraded in your body. So that thread which is used in the surgery nowadays is nylon 2, nylon 6. Okay. Now there is a small topic in your textbook, that is molar mass of polymers. As you know, no two polymeric chain will have the same chain length. So it will be very difficult to calculate their molar mass. That is why molar mass of polymers is always calculated as average molar mass. So I request you to do the self-study of this molar mass part, a small paragraph in your textbook. Please do it on your own. And lastly, I have given you just the summary of different polymers. You can see some of the addition polymers. In the first column, you get the polymeric name. Second column you get the monomeric structure and the formula of the monomeric structure. So this part is just a summary of whatever we have learned so far about the non-biodegradable polymers. So with this we come to the end of this chapter, and next we'll be proceeding to biomolecules. Thank you.